This is Google's WeatherNext to making a real weather forecast. And in this case, it is actually predicting a Category 5 hurricane 5 days ahead of time. Let me tell you what's actually happening here. Back in October 2024, a hurricane called Milton formed near the US, and it grew into one of the most dangerous kinds of storm out there. Now, here is what I did. I took the weather data for the whole planet from that day before that storm got strong. Think of it as one complete snapshot of the entire atmosphere at a single moment in time. This is a snapshot right here, the actual data I fed in. Temperature, wind, pressure, humidity for every single point on the globe at that one moment. Then I gave this to Google's model and I asked it a simple question: what happens next? And watch, with no idea what was actually coming, the model drew this. It predicted that exact hurricane hitting the coast a full 5 days ahead of time. So what you're seeing here is a dashboard that I actually built, but the intelligence behind this prediction, that is Google's. And by the end of this video, you will understand exactly how it does this and how I ran this whole thing myself on my own. And by the way, if you're new here, a quick hello, I'm Surya. I have 20 years in enterprise tech, and these days I lead an AI transformation team at a FAANG company. Basically, I take the cutting edge of AI and make it make sense. If this is useful to you, please hit that subscribe button. For now though, grab a cup of coffee and let's dive in. All right. So today, what we're going to look at is AI pointed at forecasting the entire planet. And here's why you should care. So let's say you're running a supply chain. You think of a bad storm forecast means trucks stuck and shelves empty. If you're in retail or you're a marketer, weather actually decides what people buy and when. If you're in insurance, it's how you can actually price risk before a hurricane. So weather quietly sits underneath a huge number of business decisions. And this particular model changes how good these predictions can actually get. So Google DeepMind and Google Research released WeatherNext 2, which is the second generation. And the progression from the past to this is really fascinating. So I just want to cover that very quickly, so please stick with me. So in 2023, Google's GraphCast gave you one forecast, which was a single confident answer. The problem is that atmosphere is very chaotic and one answer cannot capture that. So in 2024, the previous model GenCast made it probabilistic, but it was built on diffusion and it was a bit slow. So it was like around 8 minutes for a 15-day forecast. WeatherNext 2 is the leap. Google says it runs 8 times faster, generating hundreds of possible scenarios in under a minute on a single chip. And it isn't just faster, it is also more accurate. So what you're seeing on the screen is a chart which tells you the story. So every square here is a weather variable at a forecast range. Blue means the new model beats the old one. And look at this, it is almost entirely blue. Google's number is what WeatherNext 2 beats the previous model on 99.9% of variables: temperature, wind, humidity, pressure, basically across the board. Now, how does it actually pull this off? What is the real science behind it? There's a bit of a rabbit hole on its own. So if you're interested in understanding the actual science behind it, please let me know in the comment section and I will create a shorter explanation video on the algorithm itself. But for today, here is the plan. Let's look at the full demo first. Then I'll take you inside the notebook that I used from GitHub and show you how I actually ran Google's model. And finally, we'll also talk about how real industries can put this model to work at scale. Okay? So that's the plan. A real quick disclaimer before we get into it: all opinions are my own and do not belong to my employer. All right, with that, let's get into it. So before we run the storm engine once again, I want to show you how it actually gets there. So these are really 4 different steps and I'll try to keep it as simple as possible. So step 1 really is loading the Google's WeatherNext model. So it pulls the rates, the trained brain, straight from Google's public storage bucket. So the model comes down and runs where you are. And you can actually see it in the code. So here you can see that it is downloading the weights from the GCS bucket. And it is as simple as this one line. And I'll show you this in detail in the Google Colab as well. So the next step is actually pretty interesting because in this one, you're giving like a snapshot of the planet. So what happens is the model will predict the next 6 hours and then it will take that back and then again predict the next over and over again. So you're going to see it in the code. Here it's taking it in chunks and running it multiple times. So the third step is actually where you're tracking the storms. So the model predicts the whole planet, and a tracker will hunt down through all the data and pulls out the cyclones, tracing each one's path. So here in the code, it loops over every one of the forecasts and runs the tracker on each. So that is really the third step. And the last step is where I'm actually taking the output of the previous step in the form of a JSON. One is a track file and the second one is a build file. And this is what basically powers the entire dashboard that you saw, right? So that's the whole pipeline. So now what we will do is we will actually look at the Google Colab that I ran, and then we will go back and look into the visual aspect of it, which is what you saw in the beginning of the video. All right, so this is the actual notebook that Google has published, and I ran this on my Colab. So I won't walk you through every line because I already explained you the 4 steps, but I will cover some of the important elements. And I also want you to see that this is real, right? So if you look at this, there is some setups on the top, right? So you're installing different types of repos, different type of packages. This is to ensure that everything runs fine. Oh, and importantly, like this requires you to change your runtime to a TPU or a GPU. It is not going to work on a CPU environment. So make sure you do that when you're running this on your side on the Colab. So that's what I did. So you can see all of the imports here. So, and it continues to do that. So these are the first few steps that will require you to import. And then here is where I want you to pay attention, right? So now it is loading the data and initializing the model. So here's where you can see the date here is 2024-10-07. And that one matters because that is the exact starting point, the day before the storm. So if I continue to scroll down, you would see that this model is running 8 ensemble members. Those are the 8 forecasts, right? So this is a cell that actually does the real work. So you can see here that this is the entire code for this. So really it finds the storm and out comes those 2 files, the tracks and the wind. So that's the overall flow. So what I did was I exported that in an export.zip. You can see both the files, wind and tracks.json. And I imported this here in anti-gravity. You can see both the files are here, tracks and wind. And then I worked with anti-gravity to create the front end. So what we're going to do now is we're going to look at the front end again. So I'm going to open up the decision box here. And this is the beautiful front end that it was able to build. So as I was saying, like you can see the whole world and it is able to predict the entire storm system. So if I just start from here, you can see that there are multiple storms that it is showing. Not every storm is going to become category 5, but you can see that this is a storm which is just here in the ocean. And this is another one that it is showing. So this is what the tracker is doing, right? So it's going across the globe and trying to find all different storms that are happening at a particular time, right? So that is pretty cool. Now, what we will do is you can select the storm system and you can see that once I play this, and you can also see the number of hours, right? It is going ahead and predicting, and this is the square area where I'm trying to focus as well. So you can see that act by prep, deadline is this much. So it's able to really give a strong prediction on what is going to happen, right? And this is almost 100% that it is going to hit with a strong hurricane. Now, what you could do is, I'm thinking out loud from an industry perspective, you can define a target address and always have this kind of prediction model running. And that's where I think Google is also offering this as a managed service because this requires obviously infrastructure, a TPU-based or a GPU-based infrastructure for you to run. So you're able to run this on a Google Cloud managed service as well. Also, they have baked some of the data sets in BigQuery and Google Maps. So I leave some of those links in the description. So that was really what I wanted to cover. You can clearly see that this is a leap when it comes to weather forecasting. And again, if you want me to go a little bit deeper on the how behind the science, happy to make a video on that. But I just wanted to make sure you're aware that there are things beyond just the large language models. And this is an AI that really helps humanity as a whole. So hopefully this helps. Let me know in the comment section if you guys have any questions. And do let me know if you liked the video. Thank you very much for your time. Thank you for watching, and I will see you in the next one.